Hi, welcome to calibration for the Eora3D Java app. So first of all, a couple of hardware mods for making things easier. Normal calibration board. I've added a set square to the back to help keep things nice and square when doing the calibration. And the other change I've made is on the laser turret. I've added electrician's tape to either side of the laser output. This is to go and reduce the size of the laser line. It should be possible to reduce it by putting some resistors in series with the laser diode, but I don't want to take my turret apart in case I break it. As we all know, its hardware is no longer supported. Right, so first things first, we're going to go and detect up the Eora turret. So we'll turn that on. We're not using the turntable for this. This is purely for determining the focal length of the camera, and we're going to use basically the laser turret and our camera to do that. So everything's powered on. Just got our colour ring on the turret, and what we're going to do is we're going to hit the detect button on the app. That's going to go and fire off the Windows 10 Bluetooth stack to go and find it. It takes up to 30 seconds usually to go and find the devices. I've found I'm having to use an external USB Bluetooth 4.0 BLE dongle because the Intel built-in one doesn't work reliably. Don't know why. I've moved on to using a dongle I bought from Amazon for £7. Right, so it's now detected the turrets, changed colour, and it's now going and moving the turret back to the 0 position. So as you can see, laser serial number detected there. And what we're going to do is we're going to change the camera over to the IP camera, which is the IP camera app from the Android store. There's an equivalent one on iOS. And there we go, there's the URL for grabbing a single shot from the IP camera. Hit the calibrate button, and there we go. There's the image from the camera, and what we're going to do now is we're going to go and place the calibration board in view of the camera, and we're going to try and line it up with the on-screen grid. This is where you can see one of the issues you're going to have on doing a calibration, and you have to go and do a manual calibration within the app because I haven't got the math sorted out to do it automatically. You'll see that the board is almost impossible to get square with the image on the screen. And I think that's because although I've got the laser turret leveled with the camera and the board, the camera CCD device is not completely perpendicular to the laser turret or the desk. So you end up having to go and do some wedging around, a little bit of that there, move that around. Now ideally, by using a couple of two calibration scans, you could actually go and calculate the error that's introduced by the camera position, but I haven't got that set up. But so as a result, I'm actually cheating, and I can actually move the detection grid around and playing with it. Hopefully 3 dots. No, not quite. So trying to get all the dots in the corners green. In theory that's line up, but this isn't the best detector. I keep moving to move over to the OpenCV circle detector to improve this. Future job. I think I'm going to have to go and move the camera back a bit. Oh, wait. This is fiddly. I'll show you a manual way of doing the calibration in a second, for which all you need to do is get the image as close as possible, but you don't need the green dots because it's manual, if you're overriding what the camera's doing. Just square the board up again. close. I think if I adjust the... Oh, there we go. We had 4 dots there. Okay, so it's not precisely on. It's as close as we're going to get it. And at this point, I'm going to go and reduce the green threshold. So this is the pixel value detector, and the green content needs to be higher than this number for it to be considered a detected spot. So I'm going to move that to 80, because it will just make it just a little easier for it to detect. And just using OR, so any of these numbers that go over the threshold is considered a detected laser spot. And what we're going to do is we're going to go and hit calibrate button when all the lights are green. There we go. So now the laser's beginning to sweep. It's going to do a 5-step sweep till it goes and detects the line break inside the first calibration detection box up here. And then it'll go back and it'll do a 1-step to try and get as accurate as possible. As you can see in here, you can see what it's doing. And it's actually gone and found a corner when it shouldn't have done. So this calibration is not going to succeed. It's probably because I've got the green threshold too low. Okay, threshold, let's move that just down to 120. Calibrate. There we go. So it waited, found all green dots. Now it's doing its 5-step fast search. And again, you can see what's going on here, where it's looking for the laser to intersect with the first corner. Now these motor positions are effectively what we're looking for. The motor position on the turret when it's hitting the left hand side of the top left black dot, and the left hand side of the top right black dot. And these are the ones you can therefore manually search for. If you know what those numbers are, the configuration is fully editable. It's JSON, so you can actually go and edit it by hand with a text editor, or there's currently a configuration editor screen, although I might retire that because I moved to JSON. Right, so it's now, there you go. So it's detected the laser line going into the detection grid box, and it's now doing the single step, trying to look for break in the green line that would indicate it's hit the black dot. There we go. So it's found its notch alignment. Now it's going to look for the right hand side. As you can see in the image again, it's the board is not completely square, and it's almost impossible to get it completely square with the on-screen image and the camera, and using the set square to go and keep the calibration board perpendicular to the desk. So anyway, so I haven't got a way of fixing it currently, but I've got some parameters you can change that will go and compensate for it, and I'll cover that over in the first scan video. Right, so again, when detected the corner, so it's now doing the higher accuracy in inverted commas search for the laser line. There we go, so it's actually succeeded. It's detected those numbers. This is 3190 and 5118. And you should probably at this point config, save, and I'm going to call this cal pass 1. So if you're doing a manual calibration, you're still going to need a laser turret. Let's hit the detect button. Again, I'm going to assume the calibration board was previously set up using the calibration menu to go and have the 4 corners and the 4 squares, 4 circles and squares, so you know the calibration board's in place. And then what you can do is you can use the scan menu to manually go and position the laser to determine the 2 calibration points. Right, so we've detected our laser turret. Let's wait till it stopped jiggling about. There we go, all done. So we're going to go into the scan. We're going to go and move to where approximately where we know the laser is. Detecting, touching that left-hand square. There we go. So that's good enough. And then we're going to, so that's the configuration for the first number. And then we know again approximately where it is. Hit the laser test just to prove it out. Move this up. There we go. I mean, that's pretty much good enough for what we're going to do. Okay, so you've now got these 2 numbers that you can save in the config in the 2 numbers here. That's the important places, and that goes, and that's the detection width between the left-hand side of the 2 black circles. So using those, you can actually go. You don't have to use this calibration board as long as you go and detect something between the left-hand side of the circle, the left circle and the right circle. You can therefore do manual calibration on different boards. You don't even need these circles, but it's definitely a manual thing. Okay, that's it for the calibration, and the next video is going to be the first scan.